All right, folks. So sorry for a really long first half of class, but the good news is we only have 30 minutes left. So we're going to jump into 12.3, which is ellipses. We're probably not going to get to the calculus part today, but we will get through sort of the basics of graphing, using completing the square twice, and how you can use information to write an equation for your ellipse, okay? Again, if you're feeling a little lost with the area and the volume, I will post some of my old stuff from 150, so you can take a look at that. Or I know there are a bazillion different resources out there for volume and area, so feel free to take a look at that on your own time, okay? So I'm going to go ahead and share my screen so we can take a look at 12.3.
Quick question.
Yes, what's up?
On that very last problem, when you sat there and you broke it up from 0 to 2, and still had the 2 pi out in front, were you supposed to double that 2 pi to 4 pi?
No,
Or does
if you do that, you'll end up with twice the volume. You only want the volume. So if you take the top half and you revolve it all the way around, then you get the full volume. But if you take the whole thing, because it's top and bottom, and you revolve it all the way around, it'll end up going around twice.
Gotcha.
Okay. All right. So 12.3, ellipses, all right? So let's see how far we get today, and we'll kind of go from there, all right? So ellipse basics. When you have an ellipse, there are a few important features about it other than it looks like an oval, okay? You have a center like we had before, and our center is kind of like our vertex from the parabola. Okay, so it's the point that if we graph it, we can graph everything else from that center. So if you kind of look at the pictures to the right and left, or to the right rather, here's this center, we call it H comma K, and here's this center, we also call that H comma K, right? Now, one thing that is different is that an ellipse is actually created when you have a combined distance between 2 points, and that is the same all the way around. So what I mean by that is that this distance right here from F1 to the point, and this distance here, let's say that value is 10. It's always going to be 10, and everywhere I trace around this, every point will have a distance from that point to both of the foci that will be a combined distance of 10, okay? So we have not one focus, but 2 of them, and so the plural of focus, so more than one focus gives you foci, okay? More than one of them. And in this case, we have 2 of them, but we also have 2 vertices, or more than one vertex means we call that a vertices. So vertex, the plural is vertices, okay? Now, here's a few important points. Like the parabola, we can have an ellipse that is sort of longer than it is tall, all right? This reminds me of Ernie from Sesame Street, if you are a Sesame Street enjoyer of Sesame Street. And then we have a version which is where it is taller than it is wide, and so I kind of think of that as the Bert ellipse, all right? So you've got Ernie with sort of the wider face, and then Bert with the taller face. But either way, everything is based on the center. from the center, we can count out a certain number to find our foci, and from the center, we can count out a certain number to find the vertices. Now there's one vocab word that's not on here, so I want to put those on here. These points up here that are not the vertices, those are known as the co-vertices. And the co-vertices are the ones that go not in the long direction. Okay, the co-vertices go in the short direction. So in the BERT diagram, the co-vertices would be these side ones because they go out sideways a shorter distance than they go up and down. So graphically, that's what we're looking at. I've included a table here for you again in case you are an equations kind of person and you want to have equations so you know where to add or subtract things, okay? But I kind of want to just jump right into example number 1 and kind of use that to help us graph, okay? So very similar to the parabola, we've got an equation. We're gonna have to complete the square, and we're gonna complete the square below. Once we complete the square, we're gonna have our center. We're also gonna know how far we go to find the vertices and how far we go to find the co-vertices. Those will all be numbers in our equation. The one part that will not be in our equation is how to find the foci. And in order to do that, we're going to use this Pythagorean relation to find the foci, okay? So I'm going to take this equation right here. I'm going to rewrite it below. But as I rewrite it, I'm going to group all the x terms together, all the y terms together, and then any constants, I'm going to move to the other side.
Sure.
So what's that going to give us? We're going to get 4x squared minus 40x plus 9y squared plus 36y equals, I'm going to move that 100 to the other side, so I get a negative 100. All right, from here, we're going to need to complete the square, not once, but twice in the same equation. We're going to complete the square for the x's, and then separately, we're going to complete the squares for the y's, okay? Now, both of these have coefficients. That's going to be a very common scenario for us in conic sections. So in the x's, we got to factor out a 4. In the y's, we have to factor out a 9. So 4x squared minus 10x plus 9y squared plus 4y equals negative 100. All right, let's complete the square. 4x squared minus 10x plus half of 10 is 5. 5 squared is 25 plus 9 y squared plus 4y, half of 4 is 2, 2 squared is 4. And now I got to figure out what numbers to add or subtract to the other side. So I have this 4 and this 25. I'm hearing a little bit of feedback, so if you are not on mute, if you wouldn't mind muting yourself. I don't want to impact the quality of the video for folks who might want to watch it later. Thanks. All right, so this 4 and the 25 give me 100 that I added to the left-hand side. But since I added 100 to the left-hand side, I got to add 100 to the right-hand side. So that 100 came from the 4 and the 25. What else am I going to add to the other side?
36.
Yeah, because 9 times 4 means I have to add 36. Okay? So this is going to give us 4x minus 5 squared plus 9y plus 2 squared equals 36. The last thing we want to do is divide everything by 36 so that we make our whole equation equal to 1. Okay. Now this is the general form for our ellipse equation. And here is the defining factor. This plus sign right here tells us that it's going to be an ellipse. The plus sign, along with a squared and an equals 1, those are the 4 main characteristics that tell us that this is going to be an ellipse. Okay? I'm going to rewrite this equation above so that we can fill in the chart with our center, our vertices, our co-vertices, and then figure out how to find our foci. So we had x minus 5 squared over 3 squared, because we had 9, plus y plus 2 squared over, another way to write 4 is 2 squared, equals 1. All right, so from here, what do we have for our center? What's that going to be?
5 and negative 2.
5 comma negative 2. Excellent. So I'm going to go ahead and put that on my graph. 5 comma negative 2 gives me my center down there. Now, my vertices are going to be whichever denominator is bigger, that's what I add to either the x value or the y value. So what I mean by that, I look at my denominators. I notice that this 3 is bigger than the 2. So I'm going to add and subtract 3 from the x value of my center because it's underneath the x. So I get 5 plus or minus 3 comma negative 2. And that will give me 5 minus 3 is 2, and 5 plus 3 is 8. And so I'm able to plot 8 comma negative 2 and 2 comma negative 2. All right. The co-vertices come from the smaller denominator. So this 2, I'm going to add and subtract that to the y value of my center to get the location of the co-vertices. So we can say 5, negative 2 plus or minus 2. And that will give us 5 comma negative 4 and 5 comma 0. And so that'll be here and here. Okay. Now we have our ellipse outline, and so we can draw that in there. Okay. And again, we know that this is an ellipse because we ended up with something squared plus something squared equals 1. And sometimes I even like to determine if it's going to be wider than it is tall or taller than it's going to be wide before I draw it, so I kind of know what I'm looking for. All right, so all of that was information we could get from our completing the square. The last piece, though, to make this a complete graph is we need to find where our foci are, okay? So to find our foci, what we're going to do is we're going to use that Pythagorean relation, okay? Which is a squared equals b squared plus c squared. But c is the letter that talks about the distance from the center to the foci. So I don't tend to write it as a squared equals b squared plus c squared. I tend to write it as c squared equals a squared minus b squared. So I'm already isolating the c that I need to solve for, okay? But you're welcome to plug it into that Pythagorean relation. It'll just be an extra step where you need to subtract as soon as you plug in the number. But this gives us c squared equals a squared is the bigger number, so 3 squared or 9, minus b squared is the smaller number, so 2 squared is 4. So we end up with c squared equals 5, but more specifically, c equals the square root of 5. And the square root of 5 is what I add or subtract to the center to find the foci, okay? Now, am I gonna add it to the x value of the vertex of the center or the y value of the center?
Value.
Yeah, we're gonna add it to the x value because they're going sideways along the wider part of the ellipse. So square root of 5 is about 2.2. So I'm gonna say it's gonna be 5 plus or minus 2.2, comma, negative 2. And that's gonna give me 2.8, comma, negative 2, and 7.2, comma, negative 2. And so when I zoom in here and graph those, I should get one focus around here and the other focus around here, okay? So once you complete the square, you have a lot of the information. The biggest thing, the biggest thing is you have to find out where the foci are, okay? All right, any questions on the ellipse so far? Okay. All right, let's do one more example on this graphing, okay? So I'm gonna leave example 2 up here, and I'd like you to start completing the square, grouping your terms, and seeing if you can get to the form of this equation that will actually help us graph it, okay? So I'll give you some time to start on that, completing the square. All right. So in terms of completing the square, I hope that you grouped your x's together, your y's together, and then that negative 71, bump it to the other side to make a positive 71. Okay. Now from there, just like the previous example, we had to factor out the 16 from the x squared, from the x's, and we also had to factor a 9 out of the y's. And so once we did that, we needed to make sure we include those in whatever we end up adding or subtracting to the other side. So once I complete the square on the left-hand side, the 16 and the 4 means that I need to actually add a 64 to the right-hand side. And so this 64 comes from that 16 times 4. Plus, I need to add not 1, but 9 times 1, or 9. And that comes from this 9 times 1 on the other side, okay? And yes, that should give you a total of 144. All right, so to get this into the form that is easiest to graph in, we're going to divide all 3 terms by 144. Okay. I'm going to write this equation above, so we don't have to keep scrolling down to do all of our graphing, okay? But we should get x plus 2 squared divided by 9 plus y minus 1 squared over 16 equals 1. All right, I know this is an ellipse because I have something squared plus something squared equals 1. Is this going to look like Ernie or is it going to look like Bert?
Bert.
Yeah, it's going to be a taller ellipse than it is wide. How do you know that?
Because of the denominators?
Yeah, the bigger numbers underneath the y, right? And you can write it as 16. Sometimes I like to write it as 4 squared. Again, I'm sort of doing that pre-thinking. I'm not going to be adding 16 to anything. I'm going to be adding 4 to something. And same thing here. I might not write 9. I might write 3 squared because I'm not going to add 9 to anything. I'm adding 3, or the square root of 9. All right, so our center should be at -2, +1, or right there. To find my vertices, what am I adding where?
K plus A and K minus A.
Sorry, say that again?
K plus A and K minus A.
Yeah. What's our K in this case?
K 1
Yeah.
and plus 4 and 1 minus 4.
The
Okay.
1 plus or minus 4, right? So the 4 is the bigger number, and it's underneath the y, so we add or subtract it to the y. You can rewrite that as -2, -3, or -2, 5. You can also get that from your graph. From your center, you're just going to go up and down 4. So 1, 2, 3, 4. 1, 2, 3, 4. Okay. For my co-vertices, that's going to be where I add 3 and I subtract 3 from the x value of my center. Or graphically, from my center, I'm going to go 3 to the right and 3 to the left. So -2 plus or minus 3 comma 1. That gives us -5 comma 1 and 1 comma 1. And now I have all the points for the outline of my ellipse. Okay, and I'm almost done. The last thing I need to do is find my foci. So foci is going to be c squared equals a squared minus b squared. So c squared equals the bigger number, 16, minus the smaller number, or c equals the square root of 7. Okay, so square root of 7 as a decimal is about 2.6. And so from my center, I'm going to go up 2.6, and I'm going to go down 2.6. And if I wanted to write that as a coordinate, I'd write -2 comma 1 plus or minus square root of 7. And the approximation when you're graphing, like obviously you're not going to get super, super close or super, super exact, but around 2.5, 2.6 is fine. Okay. So let me put that all on one screen for you. But this was a case where we were able to graph this ellipse by completing the square twice, and then every piece of information except for the location of the foci is very evident in the numbers that you have. You just have to know which numbers to pick. And then the foci, you have to remember that Pythagorean relation to find out where those are located. Okay? So I think this is a good place to stop for today. I think it's been a very long day and maybe even a really long week so far for some of you, but we're going to stop here. If you have some questions, I can hang around for like a minute or two that I'm happy to help out. Okay?
I have a question, actually.
Sure.